Hello everyone, welcome to this lecture. In this lecture, I am going to discuss the implicants, prime implicants and essential prime implicants in K-maps. So before discussing all these three implicants, first we need to understand the covering functions. So let's discuss the covering function first, and then these three things I will elaborate. So what is covering function? Any Boolean function. So let's say I'm taking a function f, which is defined over few Boolean variables like a1, a2, a3, dot dot dot, till let's say an. I'm also taking another Boolean function, let's say g, which is also defined over some of the variables. So it may have the same set of variables. So let's say it is having now in case all the min terms those are present in G are also present in the Boolean function f also, and whenever this function is, let's say, returning true value, this f also supports that. In that case we can say f is the covering function of G. So if G is the subset, in a easy language you can say if G is the subset of f, then f you can conclude as the covering function. F is the covering function of G, right? So in K-map, when we define the implicants, prime implicants and essential prime implicants, we need to take care about which portion is covering which particular portion, right? So in case if I say a function f covers G and G covers f, then out of it we can conclude f and G are equivalent, right? So in case you are saying f is the subset of G and G is the subset of f, it is only possible in one condition, when both the functions are equivalent. One more important thing you need to remember, in case, so I'm saying make a note of it, if a function f is having let's say x min terms and f is defined over n variables, then total number of covering functions of f will be 2 to the power n minus x. So please do remember this particular formula in case you get any question on that, right? Let's take an example. There is a function given which is defined over four variables w, x, y, and z. Now, if I ask you how many covering functions of f are existing, so I write the question: find the total covering functions of f. So in order to find out this, we need to find out how many minterms are there. So first we need to convert it into the canonical form. So let's convert it. The function is given something like this: f w x y z, and it is equal to, so when you convert it, w and x are there, there will be four combination of y and z. So it will be y bar z bar plus wx y bar z plus wx y z bar plus wx y z. Now there's another term yz existing, so along with yz there will be further combinations of w and x. So it will be wy x bar w bar x bar yz plus w bar x yz plus w x bar yz and w x y and z. So these two functions w x y z, this minterm and this minterm, both are same. So total minterms, those are existing here in this function. Total minterms is equal to 4 plus 3, or you can say 3 plus 4, whatever. Total minterms are 7. So there are 7 minterms, and you are aware about the total covering function formula. Total covering functions is equal to 2 to the power n minus x. So what is 2 to the power 2 to the power n? N means the total number of variable over which the function is defined, that is 4, minus x means the total minterm which is there in the given function. So the number of functions are 7, that means it is 2 to the power 16 minus 7, because it was 2 to the power 4 minus 7, so it is 2 to the power 9, and the 2 to the power 9 is 512. So the answer of this question will be 512 covering function, right? Now let's talk about the implicants. Prime implicants and essential prime implicants. So what are the implicants? You consider any of the combination of variables. So let's say you are having a boolean function defined over 3 boolean variables. The boolean variables can be abc or xyz, whatever you want to consider. So let's say I'm taking a, So assume like this, I'm taking it a, b, c, and the function f is defined, which is having, let's say, a, b or c, right? So this is the given function which is having this Boolean expression like this. Now what you will get, so we will get here the combination like this, we'll get here right. So the truth table can be drawn something like this. We are having here. Now you can easily get the function values here. So all 0, it will give you 0 only. 0, 0, 1 because c is 1, the overall value will be 1 only. This will give you 0, this will give you 1 because c is high, this will give you 0, this will give you 1, this will give you, because this is 1, so it will give you 1 only, and last one will give you high, right? So this is the given function. Now if you draw the key map for this particular truth table, so the key map will look like this, and you can fill the values. This is 0, 0, 0, so it is having value 0. Now it is 0, 0, 1. 0, 0, 1 is having value 1. Next term will be filled here, so that is 0, then it is 1. Next term will be filled here, it is 0 and it is 1, and next two terms are 1. So this is the K-map. Now in K-map, all the ones you can consider as the implicants. So wherever the min term is given, every min term we consider as implicant, right? And we start forming the groups of these given min terms. So let's form some of the groups. So one possible group is here, I am highlighting, that we can form. So that group can look like this. So these ones you can form like this. This can be one possible group of these 4 ones. And another group also we can form. This one can be combined as a group with this particular one, right? So there are only 2 such groupings are possible. So these are the, you can consider the largest group which we can form, that we consider as the prime implicants. P, I am saying prime implicants, and this group is also you can consider as the prime implicant, right? So this is also the prime implicant, I am saying. This is also you can treat as prime implicant, right? Now what is essential prime implicants? Now here if you look at, there are other groupings are also possible. Before coming to the essential prime, let's try to understand the difference between implicants and prime implicants. So let's say if I define one grouping like this, I may group these 2 ones or these 2 ones like this, or I may group these 2 ones or these 2 ones like this, but that is not the biggest possible grouping. The largest possible group for any of the one combination we consider as prime implicant. Okay, although every position, every min term is an implicant, Now, what is essential prime implicant? In case of essential prime implicant, let's say if I consider this one, and this one is the part of this group, there is no other way in which you can combine this particular one, right? So this will become the essential prime implicant. So I'm saying this will become essential prime implicant. So I'm putting, let's say, asterisk here. Because of this one, whatever the minterm you are getting here, that will be acted as essential prime implicant, because there is no other grouping possible. But in all these ones, there are these can be the members of other groupings. So like this group or this group or this group or this group. So these are not the part of essential prime implicant, although this is representing the prime implicant, right? So let's solve one previous year question from GATE exam. The question is given like this: the total number of prime implicants we need to find out of this given function, which is defined in terms of min terms. So 0, 2, 4, 5, 6 and 10 min terms are given. If we draw, because there are 4 variables, we can draw it in terms of 16 cells. So 4 cross 4 K map we can draw for it. So in this K map, we can fill the values like 0 min term is given. So you know that 0 we present here, so it is high. Then 1 is not given, 2 is given as high, then 3 is not given. So these places like 1 and 3 will be considered as 0. Then 4 is given, so 4 is here, 4 is high. Fifth min term is also given, so that is also high. Sixth is given, seventh is not given, right? Then eighth, ninth not given, 10th is given here. The rest of the places are 0 only. Right? So if this is the scenario, and let's try to find out the implicants, prime implicants or essential prime implicants. So let's start forming the groups. So if we start from the group, the very first largest possible group is, we can have the combination of these two ones along with these two ones, right? So this is the one possible grouping. Another grouping, we may have this combination, these two ones can be combined because these are adjacent like this. There's another grouping possible. You can say this one is having only single possibility to form a group with this one like this. So there are 3 groups. Every one you can consider as implicant. Now these groups, if you are considering, there are 3 largest possible groups. So there are, you can say, these 3 are the prime implicants. Now what in terms of the essential prime implicants, let me highlight. If this one doesn't have any other possible combination, so I put this asterisk here, this will be the part of essential prime implicant, right? Similarly, if this one doesn't have any other choice to be grouped, this will also be the part of essential prime implicant. Similarly, if this one doesn't have any other possibility to group along, then you can say this is also the part of essential prime implicant, right? This one will not be considered as essential prime implicant, so there will not be any asterisk, right? And if this one you are not forming the group any other, then you can also put the asterisk here, right? So because there are three largest possible group which I have reflected in different color, so the total number of, because they are asking prime implicant, they are not asking the essential prime implicants, so the total prime implicants is equal to 3. So the answer of this question is 3. I think this is sufficient for the lecture. See you in the next class. Thank you for stay tuned.